Perfect. Thanks. Yeah, so I'm Soeren. I'm working at USU AI Services, and yeah, I just want to show you what we are, how we are using Flyte and how we leverage GPUs on GKE. So let's get started. So just real quick, what we are doing. So USU is a company that does enterprise service management. So a whole bunch of services, mostly for other corporate customers, managing their software assets and their IT service ticketing systems and so on. And all these things, for all these things, we are making them more intelligent. We apply machine learning mostly to automate all the boring tasks and to make these things nicer to use and easier for the customers. And we actually discovered Flyte quite early on, shortly after it was open sourced, and we were looking for a workflow engine at the time for a customer data platform. So we tried Flyte and looked quite nice, even though the documentation at that time was not in the shape it is today. Early times, but yeah, we were convinced it's the right thing for us, but for different reasons, nothing to do with Flyte. That actually, the original plan actually didn't pan out, but we helped to create the first version of the Helm chart and got to know Flyte, and then realized, wow, this is really cool also for our in-house use cases, and now are using Flyte successfully for all kinds of machine learning use cases. But how do we actually use Flyte? So we have essentially two branches. One is like, yeah, really the operationalizing side, getting ML training done and making it robust, and yeah, really making sure that things are working in production. And this is where Flyte really shines and really great, and it's working very well for us. So the other thing we actually started trying, yeah, not so far ago, is really trying Flyte also for the earlier steps, essentially for machine learning and data science experience. And we're using Flyte there also successfully, and I'll show you a little bit later on how we use it and what our data scientists say about using Flyte for experiments. So for the operationalization, I want to just show you one example where we're using Flyte for training. So this is one of the services USU provides is software asset management, and basically, in a nutshell, it means managing all your software assets and knowing what kind of software is installed on all your organization's machines, being it the server or a desktop machine. And this can help you do all kinds of things. Of course, manage licenses is one important thing. Manage and optimize so you don't pay too much or you compliant to any license and so on. But also reducing security risks because you have some old version you don't want, and do audits and so on. And the challenge, or one challenge with software asset management, is that you need to collect all this data about software. So usually you have some agents running on your machines that collect that data and put it into some database and collect all the what kind of software it is, of course, what version, which edition, and so on. Everything that's important for instance, licensing or other things in software asset management. And as you can imagine, although it is usually structured data, and it's quite heterogeneous and super messy, because basically everything can be in there, and it's also, of course, different depending on the operating system where that data is tracked, or is it really tracked at all in a structured way, what software is installed on that machine. And of course, it's a lot of data, millions of data points, especially if you have larger organizations and, of course, different organizations. And the challenge is really to map that messy data into something well structured, to some kind of catalog that you can actually use to get the information you want, right? And you can imagine if you have millions of data points, trying to do this manually or even with some rules doesn't really scale. So that's where we come into play, helping to automate this thing through deep learning. So what we are doing is we essentially take that messy installation data, and we've built a quite large, very specialized transformer model that maps this data into something nicely structured, which we can put into the catalog. So the nice thing is this is we have lots of training data. So because there's already this catalog, and this allows us to essentially do a classic supervised approach. But we need this specific model to do it, and it works quite nicely. But of course, having a large transformer model comes with its own challenges. You need GPUs, and training is not cheap. So, for instance, training a specific kind of model for this task takes 8 Tesla GPUs with combined memory of 320 gigs, and still takes 25 hours of training, even though this is a pre-trained model already. So this is, of course, expensive, and you don't want to lose state. You want to make sure this works, this runs, doesn't crash, or if it crashes, you can resume. And of course, you want to make sure you have the right fast GPU. So one thing here where Flyte really is helping us is the InterTask checkpointing feature, because when we're doing this large training job, when we're running this large training job on using Flyte, we can easily write checkpoints out to buckets, and we can also switch to cheaper machine types and to spot machines. And if the training crashes, or the spot machine goes down because someone else wants to use it, we can just spin up another machine with Flyte and resume training without losing a lot. So this is really helpful to essentially make this more robust, and also of course to save some money. In this case, in this use case, we are also using Flyte for predictions because we don't need like a real-time predictions. We can just do some batch processing. We get new data, run it nightly, and then put it into some database. And this is where Flyte is, of course, also very useful. So we also do the prediction on Flyte itself, also running on GPUs with essentially the same benefits we get for training. So this is an example of incremental training, but we can also, where Flyte is also useful, if we do like a full training on all raw data. This, of course, is going to take a lot of time, even though prediction is faster than training. If you have enough data points, it's still going to be slow with a larger model. And what we are leveraging here is essentially dynamic tasks with sharding. So we can say, okay, I want, I don't know, 32 machines with each with one or more GPUs. And then with Flyte workflow, we shard the input data, run pre-processing tasks and prediction tasks all in parallel. So this is really nice to speed up the whole process and also make it more robust. If one of these tasks fails, you have the right settings in Flyte, of course. You can also resume without aborting the whole operation. So how can we actually use GPUs in Flyte? So basic GPUs, of course, you need the support from your cloud provider, or in the Kubernetes cluster, you need the hardware somewhere for sure. But if you have GPUs available in Kubernetes, just configuring Flyte to use it is quite simple, because we can do it through resource requests. But if you have multiple GPU types available, right now it requires a little bit more effort. And we are also using a feature in GKE. I'm not sure. Probably there's something similar in AWS or something, but I'm not familiar with that. But in GKE, you can actually spin up a specific machine just through Kubernetes settings. So you essentially say, hey, you configure your pod to, and you say, okay, I need this machine type through a node selector and tolerations. And if you've enabled this feature and in GKE, GKE will essentially spin up an on-demand node pool, just satisfying your demand. So this is really nice, because what we can do now is say, okay, in my pod specification, currently we need pod tasks to do that, but we can say, okay, I need for NVIDIA GPUs, NVIDIA A100 GPUs, and if I've configured my task this way, it will just spin up the right machine for this task, and of course clean it up afterwards again. And this makes it very, very flexible, so we can depending on what we're using, what we need, we can just say, okay, give me this kind of machine type and so on. And of course, it's not only for GPUs. We mostly use it for GPUs, but it's also, you can also use this feature for other specific hardware. If you need, I don't know, the most recent machine type, AMD GPUs, whatnot, you can also use that. So this has been super helpful for us. The only issue right now is that you essentially have to set that value during registration time. So because we can't override these settings at runtime right now, but there's an open issue that's now being worked on again, and hopefully very soon we'll be able to actually do that during execution time. So saying, okay, now I need only 4, or I need 8 GPUs, or a different kind of GPU. If we can do that during registration, this would be, of course, even more awesome. Okay, so now to the next topic, and Flyte for data science and experiments. So
Soeren, before we move on, I think a couple of comments that I want to catch up before we change the topic. So I think Fabio, you were referring to the pod templates coming soon, could make that a little bit easier. I think it's a great comment. I don't know if you want to elaborate on that, Fabio.
I can. So we use the same trick for non-distributed training, but for PyTorch distributed training, you have to say task config equals to PyTorch. You can't say task config equals to pod. So there you can't use this trick. But we need it for distributed trainings because we want to switch between A100 and B100. So we had discussions with Dan, and there will be a really cool feature that I'm looking really forward to in the, I think probably next release or the one after, I don't know. That allows you to provide a pod template or the name of a pod template in the task decorator. And that will then be merged with the rest of the task config. And the great thing about the pod template mechanism is that it works for most of the plugins, right? So it will work for, I don't know the list, but it will work basically for many of the plugins where right now you can't provide a pod spec. And that's really cool because then we can also do this for distributed training with like TensorFlow, distributed training, PyTorch distributed training, and all of the others.
Yeah, awesome. Just to chime in over there, I think what essentially happens is pods and non-pod container tasks are both first-class citizens within Flyte, and Flyte actually supports them interchangeably. But like Kate, there was a decision made at some point, which is like, oh, containers and pods are in a different hierarchy. That's the combination that's happening. That should simplify. Like you should be allowed to add sidecars, etc., whatever you want to any kind of job now going forward. So that should make it, I think, super powerful.
Yes,
awesome.
That is really super powerful.
Great. Thanks a lot. Good feedback. Okay, Soeren.
Okay. Yeah. So the other thing I've mentioned before is that we've started to use Flyte for experiments. So the basic idea is to already use it earlier in the machine learning development cycle, not only when things go to production, and of course benefit from all the Flyte niceties, like caching, especially the on-demand cloud resources, including the GPU stuff I've just talked about, parallelization, of course also reproducibility, and all the insights and transparency basically we gain through workflows where you can look into intermediate results and so on. And of course also narrow the gap going from ML development prod, because if we already do our experiments in Flyte and we have a good result, it's very easy to just switch over, right? And of course also do something like tuning or trying different type of parameters. If we parameterize our task and workflows, it's quite easy to try different things and just run it in Flyte and later collect the results. And yeah, this is essentially what we've started doing. And what I also mostly for deep learning, for transformer models, for different use cases like text classification and so on. And what I've done is I've just collected a little bit of feedback from our data scientists who are using this. I just want to briefly show that to you, and yeah, maybe we can discuss or whatnot. So first the pros of using Flyte. What they're saying is it's really great for sharing experiments with the team, because of course it's multi-user and you can run your things, and then you can say to your coworker, hey, look, I've done this experiment and here are results, look it up, and someone else can have a look at the results, and also of course check out the source code and build their own experiments on top of that, or so on and so on. Also, it's quite easy to write workflows, so it's always nice feedback. And the caching mechanism can be a huge time saver. So I've seen that also firsthand for if you split up pre-processing and training, for instance, and if you iterate on your training, it's really nice. If you don't change the pre-processing, it will just be cached, right? You run your workflow again with some changes, but usually the pre-processing is just done because, yeah, it's already done, and Flyte's caching mechanism makes that kind of transparent, easy. And of course, if you run in cluster, it's all parallel, so it's also nice for experiments. And yeah, the transparency is like I've just talked about that too, right? It really helps to be able to inspect inputs and outputs, and just maybe there's some issue in between, and you can just download for instance, the Parquet file and load it into pandas or whatnot, and check the intermediate results, and this is really helpful. And also, once you have a workflow, yeah, usually it's quite reliable, so it's really simple and convenient to use and try different experiments. And if you parameterize it, you can easily, without further code changes, just run it in the cluster with different inputs, different data sets, for instance, and so on. And so what are the challenges, or what could be improved? This is not necessarily something that needs to be improved in Flyte, but maybe this needs to be some library on top or so. It's just the feedback I've collected from the data scientists. So I just want to show that here too. So one thing most of my coworkers ran into early on was trying to run some like regular Python inside a workflow decorator, and of course that doesn't work because, yeah, that's just the DSL. You just have to get used to it. But this is something, if you start, you think, oh, it's Python, I can do anything, but of course you can. So sometimes the type system and the serialization gets in the way. So if you're used to just be able to with normal function calls to use any type. Sometimes, of course, when you convert it to tasks, it's more restrictive. And sometimes, so if you use, for instance, union types, or I think one example was lists of NumPy arrays, which were difficult, and especially return values when you have to use named tuples, and sometimes you want to use data classes, but can't, because then you can't extract the values inside a workflow in a workflow. But if you use named tuples, it's hard to put the whole tuple again as a parameter to the next task and so on. This is something you have to get used to, how to actually use the API here. Then if you have caching enabled, which is usually quite useful in a cluster, and you do local testing, sometimes you don't really see that things will be cached locally too, and you run into issues because you didn't know that it was cached locally, and you wonder why it's not executing even if you change things. And then, of course, overriding the resources execution time. We just had it with the GPU examples that would be really useful. And what's also quite interesting feedback, but that maybe due to the way we use Flyte for experiments, is that people say sometimes they need more granular versioning or something like branches, because if you work on the same cluster and same project, same domain with multiple team members, and someone registers a new version, it becomes a new default, right? And sometimes you have kind of conflicts, right? Flyte is very good; you can always go to the old version, but people not used to it. Sometimes they say, "Hey, I want to do something like Git branching and just do my own stuff without even interfering with someone else." So that was quite interesting. And also, for the experiments, we were doing benchmarks, and then of course you don't want to use caching. You usually want to enable it, but for benchmarking, of course, you want to make sure that the thing actually runs. So maybe you say, okay, I'm restricting this to 2 CPUs. I want to know how fast it is, and I think there was some restriction. Maybe it's already lifted, but you couldn't. When they tried, it wasn't possible to disable caching in the UI.
That's very interesting, sir. And I think some of those things sound like data scientists getting used to different environments, just at Jupyter Notebooks. And I'm coming out of that camp, and I know all the freedom that I have, and I'm moving into a little bit more stricter environment where we talk about repeatability, reproducibility, and engineering style of work. It's a change for us. But on the other side, there's also there's also changes. I think, Keithan, you want to talk about async workflows, pure Python, real quick?
Yeah, I'll talk about a few things. So disable caching is supported in the UI now. So
great. So maybe this was just the old version. So great. So yeah, we'll try again with
Actually, kudos to Black Shark for adding support for that. So they did add it in. More of the fine granular versioning. Actually, there's a fantastic RFC in progress that LinkedIn is working on with us, and that is what is it called? Tags. And actually, you should be using authentication, and the UI will automatically start filtering if you want based on the username only.
Awesome.
And so that's like an auto branch, right? Like it's not really a branch. We don't want to build Git in here.
Yeah, sure.
But would love to hear more feedback on that. And then I think the local testing is very interesting. For the last one is async workflows. coming soon on a Flyte near you, which is essentially a way to run arbitrary code in Python, which will always become a task in the workflow. And if you're interested in contributing to that, please jump on in the contributor channel. There is a RFC work in progress. The basic implementation of that is pretty trivial, but we are trying to make it more robust because, Flyte is known for robustness. You don't want to break it by doing some random things.
Sure.
So that's what. So happy to get more thoughts on it. Right.
Awesome. Thanks, Gaten. Yeah. Cool.
Awesome. No, this is great. I love this stuff. This is the best part of my meeting.
All right. Yeah. So that's it for the data scientist feedback. Just want to kind of summarize the key benefits for us using Flyte. Yeah, it's been awesome. I think most of the points I've already mentioned, but just want to summarize. So I think one really important thing is that we have that Flyte makes these things all transparent, and we can have this insight in historic runs, look at inputs, outputs, and of course intermediate results. Everything that makes it fast, caching, parallelism, but also makes it robust, of course, reproducibility. And what has been really great for us, of course, the Kubernetes integration and the way to utilize cloud resources, but just on demand and scale up and down depending on what you need. Especially for us, the GPU support also because we have quite a lot of deep learning use cases, and also spot machines. This is great in combination with InterTask checkpointing, because you can save and still robust. And last but not least, I think a very important point is the great community. This is so important because people help each other. The Unity team has always been super helpful. So this is great. So thanks for that.
Love it. No, this is fantastic, sir. And I have a question about obviously the support for spot machines and InterTask checkpointing. You mentioned earlier on slide 8 that you were able to save time and money. Do you know how much you were able to save by leveraging spot instances?
I don't really have hard numbers, but usually GPU spot machines are I think you usually pay half the price or even less of the regular machine. Yeah, you can imagine if you're running that much GPU hours, that's quite some savings.
Yeah. I think we heard this before on the savings that's very significant. I don't know if Chief, you had comments there, or Fabio.
I have one question. My current understanding is that it tries once on a spot instance. Is that correct, or is it does it try
in the default configuration? Yes. So if it fails, it will spin up a regular instance, but you can configure that. You can not per task, but globally. So I think what we did was change it to 3 or something like that. So try a spot instance 3 times.
Okay.
And if it still doesn't work, it will just spin up a regular one.
That is so propeller config in the Helm chart, or where is that?
I think it's a propeller config, yes.
Okay. I might ping you on Slack for that.
Sure, do that.
Thanks.
Awesome.
I think it should actually, so if you specify 5 retries on a task, you should do 4 on spot and then finally 1 on the on-demand instance. That's like the fallback behavior, so that it kind of ensures completion. or progress, right?
Then the documentation is not up to date. Cool, but that's the best.
If you try it, please update the documentation. Help us.
Yeah, we will.
It's always a hard challenge.
Of course, I got it. Thanks.
Awesome. Soeren, I don't know if you have more slides. Yep.
Awesome. Yeah, just one. So there's some German in here. Sorry. So what's next for us? Yeah, I helped getting the general resource over. It's done. Also, yeah, we just heard about the pod template thing, so we're happy to help there. I also want to document the node-autoprovisioning setup, because this is a few like non-standard settings and it's not in the documentation right now, but I'm planning to add it so others can benefit there too. And also new things to try. I haven't been able to yet. Human in the loop workflows look super interesting for things like labeling tasks, and also UnionML. I haven't been able to try it, but that looks like for the for the experimentation use case, maybe it's something interesting. Okay, that's it for me. So if there are any more questions, otherwise, thank you.
Fantastic job, sir. We love it. This is really fantastic. So let's keep this going. I mean, you're also in the Slack channel, so for people who have questions, they can probably hit you up on the Slack channel, right?
Sure. Anytime.
Awesome. Thank you so much.